G'day folks, welcome to a Wednesday afternoon update. Thanks for all the great input and comments on the file hosting and that sort of stuff videos. I'm going to be doing it one step at a time. I'm not looking at doing server stuff yet. I don't have time for, say, a dedicated website or forums or anything like that, but what I will do is start by creative commenting the flagged videos, so those of you who can see them can download them and do whatever you wish. And I'll look at probably hosting on Vimeo for starters. I'll have a look at that site. I haven't even looked at the site yet, but I'll see what their conditions and things are. Essentially all I'm aiming for is a site that will allow people to watch them freely. I don't care if they get an age restriction on them, but the problem is with age restricting is certain people can't watch them. I don't mind even putting a classification warning on them, but just to deny some of my younger audience from seeing experimental things, which I don't recommend anyone try at home, simply seeing it is kind of wrong. So I'll be working on that one fairly soon, and likewise I'll be working on cleaning up this workshop a bit more. The weather's turned to crap at the moment, so we're in here a bit more, and I keep filling it up with bits and pieces, as you can see here. So yesterday I was marvelling at the neat little pump that I found, and it's like, oh, that's kind of neat, there's a little pump. And then something even bigger shows up at the junkyard today. Actually several. Yeah, giant pumps. They're out of BOC gases, Dandenong, and they're kinda heavy. I wish I could bring one home and run it, but I went through, because they're all going to be destroyed and broken up simply to be able to transport them again, I went through and got some of the plates off them. We'll start with the one that's already been broken down, which was this one. That's off the electric motor. As we can see, it is rated at 650 kilowatts, 2-pole. It's obviously by Mitsubishi Electric, Japan. Delta connection, cage induction type, 415 volts, 1060 amps. Temperature rise limit of 100 degrees over ambient, 2,950 RPM, so this thing would be singing. Weight 2,770 kilograms. That's a large frame motor, and it was made October 1980. The pump end, both the small ones are Ingersoll Rands. Oh, I've got some photos on my iPhone. I didn't have this camera, so I took a couple of photos on my iPhone that I'll try and include, but the pump itself is for nitrogen recovery, and this is just pumping air up to pressure to feed a nitrogen separator or something. I don't know how they do it, but its input capacity is 3,000 cubic feet per minute at 14.4 psi ambient pressure, like sea level basically. Intake temperature rise 95 degrees, relative humidity 80%. Discharge pressure 150 psi at 3000 RPM. Barometer on it is calibrated at 14.7. Cooling water capacity 120 GPM at 80 degrees Fahrenheit. Pretty serious stuff, made in the United States. Unfortunately, it's done its duty and it's being recycled. So yeah, that's that one. This is the big motor. It's just a motor standing by itself, and it's probably about 3 times taller than I am. Even the stator would be as tall as I am. Yeah, Toshiba Electric Japan, 2,750 kilowatts. So 2.7 megawatts, I believe that would be. 169 amps at 11,000 volts AC, 50 hertz, 2,970 RPM, 2-pole. That would make an epic amount of noise when it starts up. I wish we could start it up, but unfortunately not everyone has this kind of power supply handy. Not to mention the fact it weighs 17 tons with its cooling heat exchangers and oil tank. Ambient temp rise of 40 degrees, full voltage starting, altitude up to 1,000 meters, and it was made in 1977. Pretty good. That's off the heat exchanger that's in the base. Basco Incorporated, American Precision Industries. It's got a size code, a type code. Australian cooling tower registration PV1670.77 7mm thick shell, 128mm head. There's a radiator code there, which there is a radiator at the yard as well. It's all stainless and alloy. Maximum water pressure 0.69 megapascals. Maximum temperature 149 degrees Celsius. Pretty good. And that's off one which hasn't been destroyed yet. I haven't got to the compressor end yet, but that's the motor plate. Again, 600 kilowatt motor, 2-pole, 2965 RPM at 3200 volts, 3-phase of course. Star connection on this one, Class F installation, 124 amps, made in 1976 in the UK. But it's coupled to a Ingersoll Rand pump end, about the same as the one that I got that plate off. So yeah, as you can see, some pretty cool bits and pieces. I'll take the camera with me tomorrow. Temperature control, or thermometers, there were 4 of these, I got 2 of them. The other guy got 2 of them. Emergency stop station, a little bit rugged but still works. It's good for a drill press or that sort of thing. It's always handy to have one on the floor just in case something goes wrong, you can stomp on it and kill it. Panel lights with their own transformers, 240 volts. That one's 110 volts, not so practical, but yep. I think that's about it. We'll have a good close look at some of the stuff at the junkyard, and I'll try and include some of the photos from the iPhone on it. Oh yeah, I should mention this. That's a control panel from the one that's already been destroyed. Vibration monitors. I don't have the rest of the system for that, unfortunately. No idea what that is. That'd be discharge and inlet temp pressure monitoring, I guess. That's a thermocouple selector for all these, and that's just a thermocouple display. So I've got 2 thermocouples to go with that, which is good. I can use this as well. Yeah, really impressive stuff. My mate, who also got the other 2 thermometer attachments, got the modernised temperature controls, but they're just your motor bearing monitors. If a motor bearing starts shitting itself, it will overheat. So this is how you know when your motor bearings are failing, if they run at an abnormally high temperature, or say if the pump itself, the compressor, starts failing, your vibration monitors will start showing unusual readings. That would be kind of handy. If the control cabinet's still there tomorrow and hasn't been dumped in a bin or something, I will grab the rest of the electronics for this and try and find the sensors on the compressor end. I think I know where they are. They look like thermocouples, but they're not. I couldn't actually get one of them out. So that'll be fun. If I can try and get them out, I'll get this vibration monitor working. So anyway, that's about all for that one. And I think that's about it. Yeah, little goodies and things. I know you all love to see this sort of stuff. That's why I do it. And yeah, I figured I'd grab the plates while I had the chance. The rest of it's just going to end up as junk. Got to strip the motors down, turn the stators on their end and heat them up so that the copper windings can be pulled out. They'll just be stripped for copper down to bare steel. It's not worth doing anything else with them. But yeah, that's not bad. It's a stainless steel plate. Yeah, 2,750 kilowatts. That's a hell of a motor. And it's physically huge. I mean, I'll have to get a photo of myself standing next to it before we dismantle it, because it's one big mother of a motor. I wish I could start it up, but ain't gonna happen. Not with that kind of power supply. And I'll get the old paint off this Toshiba logo which came off the motor, because it was this logo and that plate below it. So yeah, it's been refurbished and painted over, but it's actually chromed underneath. Very neat stuff. So I hope you like looking at goodies, because that's basically what you've done for the last few minutes. Thanks for watching, thanks for the input, thanks for the support, and yeah, we've got to get back into some more projects and things here. After I cleaned up outside, like loaded the trailer up with more scrap and got rid of that. So with a bit of luck, Saturday will be dry enough and clear enough to get out there, get it done, and then focus on some more stuff in here. Thanks for watching.